A solution that contains a weak acid and its conjugate base in similar concentrations is known as a buffer. Now, we remember that when a weak acid dissolves, it forms a very small amount of its conjugate base. However, a buffer system is an equilibrium situation where we have similar concentrations of the conjugate base and the acid. Now, we remember that when the pH is equal to the pKa, the acid and its conjugate base concentrations are equal. So buffer systems tend to form around pHs that are near the pKa of the acid involved. So if we look at the dissociation of acetic acid as an example, its K value is 1.8 times 10 to the minus 5. And so if we have similar concentrations of acetate and acetic acid, for example, if the pH is 4.74, which is the pKa, these two are going to be equal, then our concentration of hydronium is going to be really small. 1.8 times 10 to the minus 5th is what it will be. And in a buffer system, we have both base and acid. So if we add an acid, the conjugate base will react with it, and if we add a base, the weak acid will react with it. And when the acid reacts with a base, it will form more of the conjugate base, and when the conjugate base reacts with an acid, it will form more of the acetic acid. And these concentrations will change a little bit, but they will still be very, very similar to one another. And the concentration of hydronium will not change very much, which means the pH will not change very much. And we know that the structure of amino acids and therefore the structure of proteins depends on pH. So keeping a pH consistent is very important for biological systems.